right, ladies and gentlemen, we are taking a look at lesson 9.6 here in our chapter. It's the last section of the chapter, and so it should be no surprise that we're looking at surface area and volume, but this time we're looking at spheres. And so our goal is going to be to calculate surface area and calculate volume. If we start with a definition of what a sphere actually is, a sphere is a set of points in space, which means it's three-dimensional, which is why we can find the surface area and we can find the volume of it, that are all the same distance from a point, and that's the center of a sphere. So just like a circle has a center, and then we have all the points that are equidistant from that, a sphere still has that same center, the same middle of the circle, with equidistant points around the outside of it. And then a hemisphere, hemi is half, so it's just half of a sphere. All right, so take a look at the follow-up, and you're going to do this on your own. We want to circle the words that differ in the two definitions below. So they give us the definition of a circle and the definition of a sphere. So you want to circle the words that differ between those two definitions. So you want to do now, and then we will check in class. All right, now what we want to do is try and draw some figures. So we're going to draw a circle with center C and a radius of 6 centimeters. So a circle is just a two-dimensional object. It's a plane object. It has a center C, so I'm going to go to my middle and label it with a C. And then radius, remember radius is the distance from the center to the edge of the circle to a point. And so we know that this is 6 centimeters. To draw a sphere, and I'll have to tell you guys I'm having to cheat here and look at the answer key because I struggle a little bit with the spheres. We're going to draw, to get this 3D shape, we're going to start with a circle. And we're going to kind of bring out the front of the circle. And we're going to draw the back of the circle. We put dashes with that because we can't see the back side of that sphere. But we're still going to have a center in the middle there. This one is labeled S, and it has a radius of 6 centimeters. So it's going to start from the center and go to the side. We can go anywhere. We can go up to a side here and label it with 6 centimeters. We could go back to this edge here because that's representing a point on the outside of that sphere and label it 6 centimeters. So, but we're going to draw a circle kind of going up and down like a clock, and then a circle going backwards to define the depth of that sphere. So let's take a look at the definitions. We need to see how we calculate surface area. Surface area of a sphere isn't really something that we can investigate through a hands-on activity. We really just take a look at this formula. So the formula of the surface area is 4 times pi times the square of the radius. So we've got that pi times radius squared that we're familiar with from area, but we're going to add in that 4. So 4 pi r squared. So that's for our surface area formula. So let's spend some time practicing that. We want to find the surface area of the sphere. We want to find the surface area. Remember, it says round to the nearest whole number. I want you guys rounding to the nearest hundredths. We're going to have 2 digits after the decimal place. So when we look at our first sphere, we can see that from the center to the edge is 8. So that means we have an r value, a radius of 8. So our formula is 4 pi r squared. So we're always going to have 4 pi. And then we're going to have 8 squared. So we can go to our calculator and type that in. 4 times pi times 8 squared. And we get 804. So 804.25. We want to have a label on that. This is inches, and because it's area, it's inches squared. All right. The nice thing about this is my label comes right from the formula. Inches squared, radius squared. All right, let's take a look at the next one. The diameter is 10 centimeters, so we're going all the way across in this diagram, but I only need the radius for my formula, so that means I want to use only half of that. So half of 10 is 5. So I have 4 times pi times 5 squared. So if we do 4 times pi times 5 squared, we get 314. So 314.16, the 9 rounds it up. This is centimeters, so it's going to be centimeters squared. All right, so you guys had the checkpoint. I want you guys to do all of these now on your own. And we will check in class. All right, so you should be able to go back and look at the 2 examples that we did, the 2 problems we did in example 1, match those up and find me some good answers. Round to the nearest hundredth, so you should have 2 digits after the decimal point. All right, so now we're going to take a look at the volume of the sphere. The volume of the sphere is 4/3. So they write that out in words. So 4/3. Hopefully when I say that, you guys are visualizing a fraction. Is 4/3 the product of pi and the cube this time of the radius? Now it shouldn't surprise us that we're cubing with volume, because that was what we were measuring volume with, our cubic units. If we look at what the formula looks like in terms of symbols, we have the fraction 4/3. So hopefully that was what you were picturing. The product of pi, so we're multiplying by pi, and then we have the cube of the radius, so radius cubed. So we're working with this radius each time. So if we take a look at the follow-up, we want to complete the following statements. For the surface area of a sphere, so you're going to need to go back and look at the formula for surface area. The radius is blank, and the units are blank. So go back and look at what we were doing to the radius in that formula and how we labeled our units. So then the volume of a sphere, the radius is blank. Look at what we do with the radius, and then the units are blank. So I want you guys to do now, and like I said, we will check in class. All right, so now let's get to some examples. Let's find the volume of spheres. We have the volume of a sphere, and then this is what a hemisphere is. It's half of a circle. And we're going to round our answers to the nearest hundredth. All right, so our formula is 4/3 pi r cubed. So I need to plug in that radius. My radius is 2, so I'm going to plug in 2 for r. And then we go through and simplify. We just multiply that. So we're going to type in 4/3. I like to put 4/3 in parentheses on my calculator. And depending on how your calculator does fractions, we'll need to look at that. And then we're going to type in pi, and then 2 to the 3rd power. Now, if you're not sure how to get 2 to the 3rd power, you're going to be able to multiply that out right now as 4/3 times pi times 2 times 2 times 2. That's what it means to have something cubed. You're multiplying by itself 3 times. So if you can't figure out how to get this exponent of 3 on there right now, that's what you're going to have to do. And when we look at that, we get 33.51. And then we want to label that, and that's going to be feet cubed. All right, so the hemisphere has half the volume of a sphere. So that means we're going to multiply that formula by 1/2. All right, so we're going to have a formula for half the volume of a sphere. So we're going to plug in this 1/2, but we also have to use this 5 for our radius. We're plugging in 2 different values this time. I'm going to go to my calculator and do 1/2 times 4/3 times pi times 5 to the 3rd power. And we get 261.80. 799 rounds up to 80. We have to have inches, and it's inches cubed. Now remember, on your calculator, some of you may have to write 0.5 times 4/3 times pi times 5 times 5 times 5. If you're not getting the same answer as me on your calculator, then we need to definitely talk about that in class tomorrow. All right, so now let's take a look at maybe an example of where we find using the volume of a sphere. We want to estimate the volume of air in a beach ball that has 12 inches of diameter. Round to the nearest whole number. So we're going to want to know how much air a sphere can hold. We don't want to put too much air in there. And so we can calculate what the maximum volume is for that. It has a 12-inch diameter. So realize if it has a 12-inch diameter, it has a 6-inch radius. So make sure you're making that calculation, that conversion. So we're going to take the volume formula, 4/3 times pi times r squared. We're plugging 6 in for that. We type that into our calculator. And we're going to have 4/3 times pi times 6 to the 3rd power. And we get 904.78. You're rounding to the nearest hundredth. And so we put the units in there. It's about 904.78 inches cubed. We can have that many cubic inches of air. All right, so ladies and gentlemen, you have good examples to look at. From example number 2, there are 2 problems that match up quite nicely. So I want you guys to do now on your own, and we can check in class. All right, you need to have all 6 of the checkpoints done to get full credit, and we will see you the next time in class.